Hello guys, welcome back to Shane's Electronics Lab, and today I'm going to be explaining the electronic generator controller that I have just recently made. And it may look simple, but it's very complicated, and if any miscalculations happen, you can actually blow loads on the outputs. But the reason why we need a electronic generator controller, is because the generator has no variable speed and or any variable speed controls, and whatever it's collecting is actually a delta variable, so it can change at any hour, any time, depending on the rain status of the weather and what it's collecting. Anyway, we're going to go over how it works. First of all, we're going to talk about the inlet. This is the generator link right here. This right here connects from the generator to the transmission line to this plug, and it goes into here. Inside the box, there is it's a filter, AC to DC converter filter module, and there's like two sets of diodes on each phase. So it filters each sine wave on the three phase that's going in, and then it goes to a capacitor, which helps refine the breaks so you don't get an annoying flickering frequency or any noise that's going through the system. Then it goes through the volt and amp meter. The amp meter is kind of redundant, but I'm going to fix that later. This will tell you the live volts that's coming in, and then this will tell you how many amps you're using. And then it goes to this buck converter. Now, if you notice that I have modified the buck converter, I took out the potentiometers so that I can seal this from water ingress. And these are actually waterproof potentiometers themselves. So these are sealed with a gasket in the back. So these are protected from water ingress as well. This allows me to control the amperage and the voltage at the same time on the outputs. This will display the amps and volts that are being used on the output taps. Reason being is to regulate the loads. Again, you don't want them exploding. We're using LEDs for a lighting apparatus here, so we don't want it to get too much voltage or amperage, or we're not going to have light, or even worse, a blackout. Okay, now after it comes from the buck converter, now we have the terminal block, which this is where things start getting very interesting. This is actually a wired in series, not parallel, and here's why. Given the fact in LED systems, or LEDs, it will give even brightness, it will take away thermal runaway, and it will pretty much act as an automatic fuse if one dies or blows out or anything like that. So I don't have to put fuses in this box right here. I made a automatic fuse from the LED lights. Okay. Now you're gonna be like, oh yeah, that's inefficient. Yes and no. There's a way to combat that. And usually when a light dies, yeah, the whole line dies. But that's what these are for. These are called short breakers. These actually short a terminal out. So say like, these are outputs, by the way. Say like on one output, one LED dies, right? It dies, and then the whole line goes dead. Well, then you're going to want to do a diagnosis. You want to turn all the lines off, adjust for maybe 3 volts at 3 milliamps. Okay, and then you just check each switch. You go, okay, line 1 is okay, lights up. Line 2, it works. Line 3 or 4 or whatever, and then till you get to a light, line 2 does not light up. Okay, that's your problem. Go out, replace the light bulb, and do a black start, and then turn everything back on. Okay. This also allows you to allocate where you want the power to come out, or whatever you want to turn on and off at the same time. So say like you want to cut a light out, and then you want to turn a light on in a different zone, and you flip a switch off, you dial the voltage in, or at least you don't want to, it's a complicated process, but turn on the next one, the light comes on in the different area that you want to use. So this system with these breakers, I designed it so that I can conserve power. And it's funny because I put bread tags on here to label the zones, which ones I can direct, which lines I can direct the power to whenever I need it. So this is actually a smart system. So very clever. Here are the outputs, and line 1 is pretty much hardwired in here. We got a plug for my lamp and chargers and stuff, and of course the light fixtures are on the side ready to go. The rain's coming in, so I decided to make a quick video about this. As soon as the rain comes, I'm actually going to be posting about how the system's running and such. So we're gonna get into more detail. The miniature, I call it the flex grid. The flex grid is ready, and I'm about to see what this beast can do. Anyway, thank you for watching. Please comment, subscribe, add a thumbs up. That would help me a lot. And have a good day.